In this video, we are going to look at guided notes for Lesson I on linear versus exponential functions. The primary difference between linear and exponential functions is that in linear functions, they increase or decrease by a constant amount, added or subtracted for each independent unit. And exponential functions increase or decrease by a factor, meaning a multiplied amount for each independent unit. Now, given the function f of x equals mx plus b, or you may have heard that as y equals mx plus b, we have certain parts of this equation that tell us it's a line. The variable x represents the independent variable or quantity. And the f of x on the left side here, or the y, represent the dependent variable or quantity. The graph of f of x is a line of the form, of course, f of x equals mx plus b, where the m here represents the number that is the slope, and the b here is the vertical intercept, or 0, b. That's the point on the y-axis where the line crosses the y-axis. Let's move this down. Now on the graphing grid below, draw an increasing linear function. So increasing from left to right goes up. In this case, your slope, m, is greater than 0. E says on the grid graph, on the graphing grid on the right above, draw a decreasing linear function. So the line would go down. What can you say about the slope of this line? In this line, the value of m is less than 0, so it's negative. Let's keep moving. The defining characteristic of a linear function is that the rate of change, also called the slope, is constant. So it's the same amount each time. And the domain of a linear function is all reals. Sometimes we write it that way, and sometimes we write it in interval notation like that. Let's look at our first example where we are comparing exponential and linear functions. In example 1, it says on December 31st at around 10 p.m. you receive a visitor. The visitor is a lawyer representing the estate of your recently deceased great uncle. It turns out your uncle left you some money in his will, but you'll have to make a decision. The man explains that you will have 3 options for how to receive your allotment. In option A, you'll get $1,000 deposited on December 31st in the bank account bearing your name, and each day an additional $1,000 will be deposited until January 31st. Option B says 1 penny will be deposited on December 31st in the bank account bearing your name, and each day the amount will double. And option C says you can just take $30,000 on the spot and be done with it. The man gave you until almost midnight to decide. Which option would you select using your intuition? A, you get $1,000 every day. B, it doubles every day starting at 1 cent. Or C, you just get $30,000. So go ahead and circle that if you have a feeling about what you would choose. Now, looking at option A and option B more closely, we can see that the number of days since December 31st. So on December 31st in option A, you'll have $1,000. On January 1st, they'll add $1,000 to it, giving you $2,000. On January 2nd, again, they'll add $1,000, and it'll give you $3,000. And then the table keeps going. In option B, on December 31st, you get 1 penny, represented by 0.01. If you wait until January 1st, you'll have 2 pennies, 2 cents. On January 2nd, you'll have 4 cents. So here it's multiplying by 2. Here on, let's see, on the 5th day, you would have 32 cents. And then to get to the 6th day, you would multiply that by 2. So that's what our option tells us. Now, if we take this all the way out to the 31st day, you can see, and you can look at them individually and see that each day this one is doubling and this one has been added by 1,000. So it looks like with option A, you're going to have $32,000, but with option B, you'll have $21,474,836.48. So let's write a model, which means an equation for this situation. In option A, you're starting with $1,000 and they're adding $1,000 each day. So that $1,000 each day is your slope right there. Now, if we would have written it in the form above, it would have been 1,000t plus 1,000, because this is your like y-intercept here, and this is your slope. For option B, you're starting with just 1 cent, so we go 0.01, but it's doubling each day, and this is an exponential function, so it'll be to the t power. And in option C, you're just getting $30,000, and that stays the same no matter what. So option A is a linear function because you're adding the same amount each time. Option B is an exponential function because you're multiplying. And option C is constant. No matter what day you're talking about, it will be the same value. So we call that a constant function. Now let's go to graph these. On the grid that's provided in our notes here, it went out 20 units on bottom. So 1, 2, 3, 4. The horizontal axis went out 20 units. But since we went to 31 days, I went and extended that line a little bit. And then it went up. My y-axis, or my vertical axis, went up 20 units also. But looking at our values here, this is what we have to take a look at in order to number our axis. In situation A, like on the 19th day, we have $20,000, so I know my y-axis has to go up to at least $20,000. And on my 19th day here, it has to go up to at least $5,200. But if I go and I jump to my 27th day, with option A, I'm at $20,000, but with option B, I'm at $1.3 million. So my vertical axis had to climb pretty steeply. That's why I didn't just count up here 1, 2, 3, 4, 5. I count each one of these little horizontal lines as $5,000. Now if we graph A, let's graph A in black. Situation A, we'll graph in black. So we start at $1,000, which I can barely put on here. On my 5th day, if I go up to my 5th day up there, I think I'm at $6,000. Let's go to the table. I'm just going to graph some points. You can see here on my 5th day, I'm at $6,000. On my 13th day, I'm at $14,000. On my 22nd day, I'm at $23,000, etc. So if we graph those points, that will help us graph option A. So we start at $1,000. On my 5th day, I'm at $6,000. On my 10th day, I would be at $11,000. On my 15th, I'd be at $16,000. On my 19th, here, this would be 19, I'd be at $20,000. My 24th day, I'd be at $25,000. And my 29th day, I would be at $30,000. So I'm getting these points by going over here. This is $30,000. Then we try to graph that line. Oh, we'll call that good. That is situation A. Let's graph situation B in blue. All right, looking at the numbers, I have them printed out here so I don't have to scroll back. On day 1, I'm at 1 cent. So that, or day 0, I'm at 1 cent. That's really close down here. Even if I go down to day 10, I'm only at $10. Day 10, I'm only at $10. That barely registers also. At day 15, I'm at $327. So that's right here. At day 20, I'm at $10,485. 10,000, so that's only right here. At day 25, holy cow, at day 25, I'm at $335,000. That's off the chart. So let's go to day 22. Day 22, I'm at 41,000. To be, let's see, here's 40,000. So if I follow this line, day 22 is just going to be a little higher than that line. Day 23 is 83,000. So this would be day 23. I'm going to go up to 83,000, which is going to be somewhere like that. So we start off much lower. But this is what we call a concave upward curve, because it just does this, etc. So this is the graph of B. Now the graph of C was just $30,000 no matter what. So this is what a constant graph looks like. This would be, whoa, that would be graph C. All right, so that depicts the money we would earn with those different options. Now let's talk about domain and range. Domain is our x values. So we're talking from 0 to 31 days is where the chart goes, but in actuality, you're not going to die at the 31st day. So the domain really goes from day 0 until, let's say, you live for a very long time. For all of these options, the domain is going to be the same. It's going to keep going and going and going because you're young and you have a long life ahead of you. You don't know when that will stop. Now the range, all of these ranges, none of them start below 0. The first, with problem A, you started at $1,000, so the left value is 1,000, and then you wound up with 32,000 at the end of the table. Another way to write that is, let's see, this is A of t, is to say you started at 1,000. This is inequality notation, and you wound up with 32,000. Now, if we look at B, you started at 1 cent, so we'll do it. And this is my B function, so I'm going to call that B of t. But then it went up. The highest value on the chart, without looking up, you guys can look up, is, holy cow, 21,474,836.48. So that is option B. Now for option C, it was $32,000 no matter what. So the range is just that value. Our range tells us the y values that are depicted in the graph and on our y-axis here, our vertical axis. All right. So based on the graphs, which option would give you the most money after 31 days? Well, obviously option B. We're going to go with B. Let's keep rolling here. Okay. Let's see if we can understand why option B grows so much faster. Let's focus just on option A and B. Take a look at the data in the tables given for each function. Just the latter part of the initial table are provided. So this is from day 20 on. And here's our function for our exponential growth. When we double each time, that doubling amount is the number that gets taken to the power. And here's our linear function for adding $1,000 each time. Now, this question asks, as t increases from day 20 to 21, describe the outputs change for each function. So, here for function A, that's the first table, as we go from 20 to 21, we add $1,000 to get from $21,000 to $22,000. On option B, from 20 to 21, we multiply by 2. So we multiply by 2 to get from $10,485.76 to $20,971.52. Let's look at the next part. It asks, as t increases from day 23 to 24, again, for A, we add 1,000, and for B, we multiply by 2. So this is add 1,000 in the linear function, and here we're multiplying times 2. So I'm just going to write that here. Add $1,000, and you get from 24,000 to 25,000. And here we multiply by 2, and that really increases a lot, from $83,886.08 all the way up to $167,772.16. So in general, we can say that as the inputs increased from one day to the next, the outputs for each function, this one increases by $1,000, and this one doubles. In other words, A of t grows linearly because it's increasing by a constant amount, and B of t grows exponentially. All right, this concludes our first video on lesson I. I hope it was helpful, and we'll see you in the next one. Thanks for watching.